kindly go through the assignment 2 file. Okay, we have given the next contest link, which is this one. So in this lab, we will focus on a new concept actually, like it's called two-pointer technique. So in your theory, I guess you guys finished binary search, ternary search. Two-pointer technique is like a similar concept, but not the same. So even in this concept, there are pointers. Like in binary search, there was left, right, middle, which you also covered in other courses, I think. So here it is also a similar concept. We come with two pointers. That is the main name, right? So there's a starting index, there's an ending index. Okay. There's a starting index, ending index, but it is not necessary that all of the solves have to be like this, that it has to start from 0 and end at n. Like this can be considered left, this can be considered right. But the main thing is that we will somehow come to a common conclusion by using these two pointers. And another thing is that we cannot overlap or exchange positions. Like if I'm going from left to right and here right to left, we will somewhat um, come to a middle point or similar scenario actually in most cases. So I'll go question by question. We will mostly cover 3 questions, I think, today. Then you will have a good idea of this concept. So you can solve a question using complete brute force, which is just using linear search or any nesting loop solution basically. But the issue is obviously our tasks have limited resources, right? So let's go into a task that we have a set time, which is 1 second. Mostly for all tasks, this time is 1 second. So if you want to do the code efficiently, you need to shift to the two-pointer method or even binary search method if needed. So the brute force method obviously solves the question, but not the time issue. So that's that. So let's look at the first question here. Okay, can anyone tell me, like 1 second, by 1 second, how many tasks can be completed? মানে আপনাদের কি ক্লাসে বলা হয়েছে যে 1 সেকেন্ডে অ্যাকচুয়ালি কতগুলা টাস্ক করা হয় বা লুপ কতবার ঘুরে কোডের জন্য? কেউ জানি? আচ্ছা, একটা রাফ এস্টিমেশন করা হয়েছে যে আপনার 10 to the power 8, 10 to the power 8 times the loop can run in 1 second. This is a rough approximation basically. So if your time is mentioned 1 second here, you need to understand the input or the loop cannot run more than this. So here, let's read the task. It's a do some trouble problem. Your little brother Bob loves playing with integers. One day, his teacher gave him a sorted list of n integers. Okay, so this is the main input, sorted list of n integers in non-decreasing order. So can anyone tell me what is non-decreasing order?
Sir, only ascending order.
Um, Partially correct. Okay. So non-decreasing, it means increasing, right? It has to be increasing or ascending. But the thing is, then why not just write increasing order or ascending order? So the main thing here is that another scenario we have to consider, which is, let's look at this one. Yeah. This is a increasing order, right? But the thing that is different here is that there are also equal numbers. So by non-decreasing, we mean that the number can increase left to right, but the number can also be the same. So these two scenarios we need to consider while solving these issues. Okay. I think most of your problems are like these non-decreasing order problems. Okay, so you got an integer for the list count. Now your brother wants to play a game with you. Bob will give you an integer s. You have to find if it is possible to find two values from the list whose sum is equal to s. So you are given length n and you are given a target value of s. These are your two inputs, like this one, 4 and 10. Um, then the first line contains two integers, n and s, denoting the length of the list and also the target sum. In the next line, there will be n integers in non-decreasing order, separated by spaces. সো আপনাদের আউটপুট যেটা আনতে হবে সেটা হইলো প্রিন্ট টু হ্যাঁ কিছু বলতেছিলেন আচ্ছা না প্রিন্ট টু ডিস্টিংক্ট ওয়ান বেসড indices I and j such that ai plus aj equals to s where I less than j. Okay, so can anyone tell me what is one based indices? আচ্ছা, so আমি বলি ওয়ান বেসড indices হইলো আপনাদের indexing. It starts with 0, right? Indexing starts with 0. So we can say this one is 0, this is 1, 2, 3. So this is how our file structures work in array, right? Our first element is under the array index 0, then sequentially it goes up. But in this task, the output is asked to be 1 based indices. So the indexing now starts from 1, not 0. Okay. So this will be 0, this will be 2, this will be 3, this will be 4. So this is not like the whole structure, actual structure changes. It is like you have to solve in a way that the indexing starts with 0, like usual, to n. But while outputting the indexes, you will just say this is 1 and this is n plus 1. Okay. Just remember this, while outputting, you just need to change it, nothing else.
স্যার,
হ্যাঁ বলেন।
এখানে কি আউটপুট অ্যারে হবে মানে?
না না, ওইটা বলতেছি আউটপুট অ্যারে হবে না অ্যাকচুয়ালি।
আচ্ছা,
সো
তাহলে কি জিরো ইন্ডেক্সে এমটি থাকবে?
জিরো ইন্ডেক্সে এমটি বলতে?
মানে স্যার নাল ভ্যালু বা এরকম কিছু থাকবে, মানে জিরো ইন্ডেক্সে কি হবে তাহলে?
না না, আমি ওইটা যেটা বলতেছি যে জিরো কিন্তু আপনার আছে, এমন না যে জিরো নাই। যে আপনাদের জিরো ইন্ডেক্সে
হ্যাঁ।
কিন্তু ধরেন অ্যারের জিরোতে স্টিল কিন্তু ওয়ান আছে এই অ্যারে হিসেবে, ঠিক আছে? এই অ্যারের কি প্রথম এলিমেন্টটা
আচ্ছা,
ওয়ান না?
জি স্যার।
The first element is 1, so it will remain 1. But while outputting, if I need to show the index number of 1, যদি আমি এই 1 এলিমেন্টের ইন্ডেক্স বলতে চাই, আমি তখন বলবো যে ইন্ডেক্স আসলে 1 নট 0, ঠিক আছে? খালি এক বাড়াই
ও,
দিবেন ইন্ডেক্সের কাউন্ট, নাথিং এলস।
জি,
So
থ্যাংক ইউ স্যার।
similar to that, if I want to print 7, this is in the index number 3, okay? This is index number 3, but while outputting, I will just say 4 or the fourth term, okay? Just you can say in a way that first term, second term, third term, like that. Okay.
ওকে স্যার।
So what is mainly asked here? Um, we need to find a target values indexes. So let's break down the task a bit. I'm directly going to a sample scenario here. So the first value is number of elements in the array. The second value is the sum target. So somehow we have to manage that the sum target has to be 10, basically, sum target. Now, what do we sum? We need to sum two elements. So two elements sum have to be the same as this target. Okay, that is what is mentioned by AI or AJ. So if the array is A, then a somewhat value of AI and somewhat value of AJ has to be equal to S. or our target value. Okay. So let's see here. I'm going to sum 1 and 3. Okay. So 1 plus 3, is it equal to 10, which is our target
No.
value? Obviously, no.
No.
So this can be the scenario. Then let's say 1 plus 5. Can this be 10? No. Then let's try 1 plus 7. That is also not possible. Like it's 8, so it is not 10. That is why I'm saying not possible. So our answer is basically 3 plus 7, like this value and this value. Only this sum is equals to the target value, right? Our target value is 10. It's like basically like a game. We have to reach a certain value. So we reached 10 from 3 plus 7. So our output has to be the index numbers of 3 and 7. So 3 here is in 0, 1, and 7 here is in 2, 3 number index. So 1 and 3, basically the second term and the fourth term. These are our outputs, okay? So we just need to find a pair which is equal to our target and then show their index numbers. And the index numbers are 1 base, so it starts from 1. Just add a 1, nothing else. So not a very challenging task, but um, I hope you guys understood what it is meant. আপনারা কি বুঝছেন বেসিক্যালি কি চাওয়া হয়েছে? যে
জি
আপনার
স্যার।
অ্যারে লেন্থ বলা হয়েছে, টার্গেট ভ্যালু বলা হয়েছে। এখন অ্যারেটা থেকে যে কোনো দুইটা ভ্যালু যোগ করলে ওই টার্গেট ভ্যালু সমান হইলে আপনারা ওই ইন্ডেক্স গুলার জাস্ট আউটপুটে বলবেন, আর কিছু না। And now let's say your target is not present in the input array. So what will be the output? The output will be -1. Like here, it is asked, where's my mouse? Okay. So 4 terms, the target value is 7. So in no combination we can reach to 7 actually. Like we can try like 6 plus 2, it is 8, not 7. 4 plus 8 is 12. So it is not possible from here that we can go to 7. So output would be -1. In most CP tasks actually, if there is any invalidity, usually -1s are printed actually. Okay. So let's try to think of an solve here, right? So can anyone tell me how do you think this can be solved? No need to think about the efficiency right now. Just any solve can work.
স্যার ব্রুট ফোর্সে স্যার দুইটা, মানে একটা নেস্টেড লুপ রাখবো আর তারপরে স্যার প্রত্যেকটা যোগ করে টার্গেট ভ্যালু ইয়ে করবো, এন্ড
Yes,
যেটা ম্যাচ করবে সেটা দিয়ে।
yes, that is a solve, obviously. So the brute force method, or you can say nested loop method. So I've already done that solve, but the issue is your time limit is 1 second. So when you try the brute force method, let's look at the solve first. Okay. Here is a brute force method solve. If you try this, what happens is that the max, um, you can say the max value here, the number of arrays possible is 10 to the power 6. Okay, so that is our max. So this loop, the outer loop, this will run max 10 to the power 6 times. Okay, and our limit is 1 second. So 1 second, I've said that it is roughly 10 to the power 8 repetitions of a task. So this is obviously possible, but the thing is, main issue is that um, we know a nested loop is actually order of n square. So if I say 10 to the power 6, so 10 to the power 6 actually 10 to the power 6 into 10 to the power 6, which is 10 to the power 12. So this exceeds our 10 to the power 8 threshold. So that is why time limit exceed is showing. Like it took the um code. Like here the verdict is okay, here is also okay. All the up to test case 4, the verdicts are okay, but after that it won't work. So basically for not all scenarios our solve is working. So we need to go for a more efficient way. I'm just showing you this, that this is also possible obviously. So just the loop, then inside it another loop, just one index apart. Then we are summing the array elements from the left value to the next value, then just matching it and just printing the indexes. Wherever it is same as the target, the value would be shown. Other than that, it would print -1. That is the case here. Okay, so let's think of a better solve here. So I'm directly going to the two-pointer method. Okay, what do we do in a two-pointer method? So let's take this first case. So 4 array elements, our target is 10. So this is our target. Let's say the target is S. Okay, and the input, first input is N, and the values are 1, 3, 5, 7. So I know which ones will work, but let's say I don't know it. And initially, let's say I have a left pointer which starts from the 0th position. So in the left pointer, I have now 1. And let's use a right pointer which uses n minus 1 for now. So n minus 1 is, in this case, actually 0, 1, 2, 3. So this is pointing to this. So let's start comparing. So in L and in R, let's take two variables. L, I have 1. R, I have 7. So 1 plus 7 is basically 8. So this is obviously less than our target value 10. Okay. Now, our main thing we have to look here is that in our problem, it is actually sorted, right? The array is sorted. So in a sorted or partially sorted. So it can be half sorted. Okay. So in a sorted or a partially sorted array, we can use this two-pointer technique. It won't efficiently work in other scenarios. So in a scenario like this, we can say that if we are going from left to right, the value is increasing, right? The value is increasing. Now tell me, 8, is this greater than 10 or less than 10? It is
Less than.
obviously less than 10. So we need to increase our sum value. So this is the sum value. We need to increase the sum value so that we can reach the target. So we can say that we don't need to reduce value, we need to increase the value. So as I have said, we are using a non-decreasing array. So from left to right, our value increases. So let's increase the left pointer so that we can go closer to our target. Okay. So we have to make intuitive decisions basically. We cannot just go hilly-nilly and just increase the indexes. We need a cause for that. Okay, so our cause is basically we need to increase the sum value to reach the target. So we are now going from left to right. So our left index goes a bit right to the 1 index. So in the 1 index, our value is 3. Okay, so this is 3 and the right index remains the same. So 3 plus 7 is the next scenario. So here we got actually 10. So in just the second iteration, we got our solve actually. But if we went blindly like um, 1 plus 3, then 1 plus 5, it wouldn't work, right? I mean, it would work, but in a later case actually. So let's take another one like this one. So our target is 18. So if our target is 18, and let's say the array is number of element is 6, target is 18. This is S. Okay. So we start with 1 and 10. So the value is, where is the mouse? 1 and 10. So let's start with these two. So it is 11, obviously less than our 18. So now let's go up to 5. So this is now 5, 5 plus 10. So 5 plus 10 is 15, which is also less than our 18. So let's go another step ahead. So 18, sorry, 8. So now we're summing 8 with 10. Again, we have reached our actually solve. I want to do a different thing actually. Okay, so let's say for some reason this is 9. Okay, then what will happen? Just I'm modifying the array. Okay, so if I'm modifying the array, let's say this is 9, then the sum will be 19, right? So 19 is obviously greater than 18. So we are one off from our target, but this time the sum we have calculated is greater than our target. হ্যাঁ কেউ কিছু বলতেছিলেন? আচ্ছা না. So this time our target is actually less than our actual sum we have done. So what we need to do here is that from for all other scenarios we went from left to right, but now we actually need to decrease our value. Okay, so if we need to decrease our value, we do not change our left pointer, we change our right pointer, because we know the right pointer has the greater value basically. So we need to decrease to a lesser value for the right pointer. So if we go from 10 to 9, actually our solve works here. So then we are saying 9 plus 9. So it reached our target value. Okay. So we have to consider these two cases basically. Then our task is easier. So if the sum is less than our target value, we need to increase the left pointer by 1. And if our target value is 1 less, then we have to reduce the basically right pointer. So from right we go left and left we go right. This is mainly our usual solve or a 2 pointer technique. Okay, so কারো কি কোনো কোশ্চেন আছে এই প্রসেসটা নিয়ে যে আমরা কেন এটা করতেছি বা কিভাবে করতেছি?
স্যার, আমার একটা কোশ্চেন আছে যে অ্যারেটা যদি অড ইন্ডেক্সের হয়,
হুম,
মানে মাঝখানে জাস্ট একটা ইন্ডেক্স আছে, তখন কি হবে? যে লেফট পয়েন্টার ইকুয়ালস টু রাইট পয়েন্টার যদি হয়ে যায়।
লেফট পয়েন্টার ইকুয়ালস টু রাইট পয়েন্টার, আচ্ছা। So আমরা লুপ এমন ভাবে কন্ট্রোল করব যাতে কখনো এটা না হয়, বুঝছেন? তার আগে আমরা সলভ পেয়ে যাব। যদি না পাই তাহলে আলটিমেটলি -1 এসে পড়বে অ্যান্সারে।
ওকে স্যার।
কখনো ওই দুইটা সেম হইতে পারবে না। বেসিক্যালি আপনার লেফট রাইট যেটা বলতেছেন, that is binary search actually. Binary search we need to go to a target value also, but then the left and right pointer should show the same index basically, or the middle value. But in this technique, this looks a bit like binary search, but it isn't, because of that scenario only, that we do not go to the middle value, we reach to the end from left or right, any end. Okay, so
স্যার,
hopefully
তাহলে কি মানে যদি যে লেফট ইকুয়ালস টু রাইট হয়, তাহলে কি তখন লুপটা ব্রেক করে দিব?
হ্যাঁ, ওই লুপটা ব্রেক করে -1 প্রিন্ট করে দিবেন।
ওকে স্যার।
আচ্ছা, so let's look at a solve actually. um which one? Okay, submissions. Okay, let's look at this solve. This has been accepted and the time is obviously less than 1 second. So what I have done here is that um, I'm skipping this part since you guys already submitted the assignment. So let's look at this mainly. So obviously I'm started with 0 and n-1 as I've said. And now look at the left loop controller. The loop controller is left less than right. Okay, so we cannot go to a single middle index. So middle index cannot be our solve. Or if we reach the middle index or the left or right pointer now points to the same thing, then our loop breaks. Our loop breaks and prints -1. Okay, the scenario you talked about it a little while ago. Okay, so the current sum is obviously array left plus array right. Then if current sum equals to S, we have reached our solve. Then now this is the thing you need to understand, that I've said it is one based indexes, right? So one based indexes means the output just needs to be +1, but the usual indexing is same. So our left right we have in all other scenarios kept the same. Only while printing we have just added +1. So this satisfies our solve actually. So then we return. Now, if the scenarios I said, the current sum is less than the target, what we do? We need to increase the value obviously. So left pointer just plus ones, nothing else. We do not use to change the right pointer. And in the other scenario where the current sum is greater than the target, we need to decrease the right pointer and go a step back. So this is basically also a very easy small solve. Okay. So কারো কি কোনো কোশ্চেন আছে সলভটা নিয়ে?
স্যার,
হুম।
যদি মাল্টিপল পেয়ার থাকে, তাহলে কিভাবে, মানে সবগুলা কি পরপর প্রিন্ট হয়ে যাবে?
আচ্ছা, মাল্টিপল পেয়ার হইলে আমাদের এই সিনারিওতে অ্যাকচুয়ালি মাল্টিপলের কথা চিন্তা করতে বলা হয়নি, বাট যদি মাল্টিপল থাকতো অ্যাকচুয়ালি প্রথম যেটা পাইতো ওইটাই প্রিন্ট করে বের হয়ে যেত। কারণ দেখেন এই যে প্রিন্ট দিয়ে কিন্তু আমি রিটার্ন দিছি, আমি কিন্তু এমন না যে লুপটা চালাই যেতেছি, লুপটা তো থামতে হবে। সো দ্য লুপ উইল এন্ড ইফ উই ফাইন্ড আ সলভ, হুইচ এভার সলভ ইট ইজ, ডাজন্ট ম্যাটার। ওকে।
ওকে স্যার, থ্যাংক ইউ।
সো এইটাই। ডাজ এনিওয়ান হ্যাভ এনি কোয়েশ্চেন উইথ দিস সলভ অর দ্য ফার্স্ট সলভ? ওকে, হোপফুলি নট। সো let's think about it again. Like, can it be solved in any other way? Right? You have what are you doing basically here? You're searching for indexes, right? So where have you learned searching? Binary search, ternary search. So can we use binary search here? Let's think about it a bit. Since Agumoni Apu has taught you guys binary search recently, I saw. So can anyone tell me, is it possible to use binary search here? আচ্ছা, কেউ যদি না বলেন, তো হ্যাঁ, বাইনারি সার্চ নর্মাল সিনারিওটা কি, আমরা বাইনারি সার্চেও না একটা টার্গেট খুঁজি, বাট ওইখানে কি আমি একটা ভ্যালু বের করি বা একটা ইন্ডেক্স, টার্গেট ইন্ডেক্স বলতে পারেন। আমাদের এখানে কি একটা ইন্ডেক্স আমরা বের করতেছি? আর উই লুকিং ফর অনলি ওয়ান ইন্ডেক্স অর টু ইন্ডেক্সেস ইন দিস সলভ? We're actually looking
টু।
for two indexes, right? A pair. So we need to modify the thinking a bit, that how can we say that um, we are actually looking for one indexes. So if we want to do that, that is possible. But the thing is, I have done this in a binary search solve also. Okay. Let's just compare the times a bit. Mm, like here, this is my usual solve, the two pointer solve. Then this is my, yeah, this one is my, oh sorry, এটা তো Java, Python একটা আছে, Python এটা. So this one is also accepted, right? But this is 312 ms and the first one was 296 ms. So basically, I also went for a binary search solve, but that is more than the process we use in our two pointer solve. So basically, you could say that two pointer is less than um, binary search. Okay, so if you are getting TLE somewhere, but you're using binary search, you could go for two pointer solve because it is a better um, value in some cases. Okay, so let's figure out why this is actually. So let's look at the binary search solve. It is this one, yes. So for the binary search one, I have for Python people, actually I imported bisect. So this is allowed in this course because actually we are wanting efficiency, and you guys already have learned binary search. So basically, what is happening? This is using a C++ version of binary search. We know C++ is way faster than our Python. Okay. So that is why I can do it, because it is a more efficient way. And then I'm using its properties to find the value actually. So let's look at the binary search one. So in binary usual terms, what are we doing? We are, let's say, a plus ai plus aj. We're going to a target value, right? We're going to a target value. But let's say what is constant in our cases. Like if we look at this scenario, 7 is constant, but we need to find two indexes. So let's say the first index is fixed. For some reason, I'm thinking of it as my first element is fixed. So let's say 1 is fixed. So a j, or you can say the right pointer is our variable here. So we need to find a right pointed value which will ultimately reach our threshold or the target value. Okay. So this is constant, this is constant. We need to find this value. So now can this be solved through binary search? Now this can, because we are finding for one, um, let's say a one index. Okay. One index is fixed. The target is fixed. We are looking for the another index basically. And obviously this value is sorted. So binary search will work on it. So let's rearrange this a bit. So the target we are searching for now is AJ, which is equal to 7 minus 1 basically. So somehow I have to make this, let's say 6. Okay. So this was a dummy value actually. In your case, it is 1 plus AJ equals to 10. So in your scenario or the first case, we have to find a value which is equal to 8. Okay. Is equal to 8. Now, the issue is there any 8 here? There is no 8 here, right? So ultimately, after one loop iteration, we need to change this. So it can't remain 1 plus AJ. It has to be then 3 plus AJ. Okay. 3 plus AJ equal to 10. Then what is AJ? AJ is actually 7, right? And we have 7 here. So we can reach this value. So in the binary search option, there are different cases. So obviously for one case, it will match. If we keep it constant for one round, it is okay. But for the next round, if we do not find our targeted sum, we need to change our left pointer. So in binary search perspective, left is constant, but only for one round. Okay. Left is constant only for one round. So if in that one round we cannot find the value, we are going to the next round. Okay. So let's talk about the time complexities a bit. So our previous solve actually. Can anyone tell me what is the time complexity of this one? The previous one we saw, two-pointer method.
O of n.
Yes, O of n. So we got a linear value actually, because what we're doing is that we are going from left to right and right to left, right? So what this
Yes,
is happening, basically we are spanning the whole number, right? Or the
yes.
array length. We are not overlapping, we are not nesting. So basically we are doing it in one loop, you can say. So what is happening here is that we are keeping it constant, right? One value is constant. Then for the variable, we are changing the values like this one. This is constant. We're using this as a variable. So if you're keeping one constant, this one, AJ, can run for n times, right? If this is basically কি বলে এটা যদি কনস্ট্যান্টলি থাকে আপনারা লুপটা কিন্তু n বার চালাবেন এই n বার যদি সলভ না হয় তখন কি করবেন this increases to let's say 2 then again for this we are running it for n times the age, right? So in worst scenario we are changing this left pointer n times and we are using this loop n times, but this is actually not n. What is the time complexity of binary search? The time complexity of binary search is actually log n, right? So we are log n times searching the value for worst case scenario. So ultimately, our time complexity is n into log n. Okay. For this task, the time complexity is n into log n because the constant we are talking about is actually not the constant if we cannot find it in the first try. So we are changing at max n times, and the binary search time complexity is log n. So ultimately, n log n is our time complexity for this task if we use binary search approach. So this is obviously more than our two-pointer method, which is order of n. So this is order of n log n. So obviously it is more than our two pointer method. Okay. So I hope you guys understood why binary search works, but why it is not preferred here. So for our lab tasks here, basically all the tasks you could use two pointer method. I think only one question explicitly thinks about binary search. We're not talking about that one, but for all other tasks, you can use two pointer method because it is more efficient. And we can also compare the times, like two pointer one is 296 and here it is 312. Okay. But it is obviously not true for every scenario. For our scenario, which is sorted, we just need to find two indexes. This could work. Okay. So, does anyone have any question about the binary search option? This is just using a function actually. So I'm not describing much about this. You can look into the bisect left method, how we are doing it. So basically, we are looking for a, since I saw you, since I'm showing you the, let's say, simulation, you already know that we are actually finding the next value, right? So this starts from here, I plus 1, then we are searching for an index for which it reaches our target value, which is k. Okay. So like this you can actually solve this. So this function, as far as I know, um, provides a positive value if the index is found, or a negative value if the index is not found. Then the loop again runs. Okay. So you can, y- when solving, you can look at this while watching the class recording actually, because this is not an efficient way. I prefer that you go for the two pointer approach actually. Okay. So
আচ্ছা, আমি
does
তো এখানে অ্যাড করি। হ্যাঁ,
uh,
সো স্টুডেন্টস তোমাদের এখানে যেরকম দেখো যে আমরা যেরকম জাস্ট এখানে বাইসেক্ট এই মেথডটা ইম্পোর্ট করে কাজ করতে পারতেছি, রাইট? বাট তোমাদের আরেকটু খেয়াল করো, সেটা হচ্ছে যে যদি কোনো রেস্ট্রিকশন থাকে ফরবিডেন কিওয়ার্ডের মধ্যে, যে কোনো বিল্ট ইন লাইব্রেরি ফাংশন ইউজ করা যাবে না বা বাইসেক্ট এই টার্মটা ইউজ করা যাবে না, তখন কিন্তু আমরা আবার এটা ইউজ করতে পারবো না। তখন একটু বাইসেক্ট মেথডটা জাস্ট স্যার যেরকম আগের বার দেখালেন ওই লো পয়েন্টার হাই পয়েন্টার নিয়ে ওরকম করে একটু ইমপ্লিমেন্ট করে ফেলতে হবে। এই যে এটা এই ভার্সনটা বুঝতে পারছি সবাই? ও ও স্যার, এটা তো মনে হয় এটা
আচ্ছা আচ্ছা, হ্যাঁ
টু
বাইনারি।
পয়েন্টার। হুম, বাইনারি সার্চের যে, হ্যাঁ তোমাদের ক্লাসেও কোড দেখানো হয়েছে, ওই জিনিসটা একটু জাস্ট 2 লাইন কোড লিখে নিও, একটু ওয়ার্নিং আর কি।
আচ্ছা, so let's look at the Java solve. I think I have the Java solve too. It should contain the, yeah, this one. Okay, so for the Java people, you can also go for a binary search method, which is this one. There is also a built-in one here. So this is the same way it works. And obviously the Java code looks bigger because of the fast IO things. So I hope you guys understand how fast IO works now. So even for Java, there is built-in method. So you can use Java IO, Java util, then you can use the binary search methods too. Okay. So arrays, binary search, then you can put in the values. So search a bit how this works, because this is not actually um, need to think about many things here. Okay. Basically, just if the position or the index is found, this value will be positive. If it is not found, it will be negative. Okay. So কারো কোনো question আছে task 1 নিয়ে? Does anyone have any question with the task 1? আচ্ছা, হোপফুলি বুঝছেন সবাই। সো এই টাস্কটা ইউজ করেই না আপনারা আরো প্রবলেম সলভ করতে পারবেন, ঠিক আছে? আমাদের যে প্রবলেম গুলো দেওয়া আছে, ইউ ক্যান সলভ আদার প্রবলেমস ইন আ সিমিলার ওয়ে অ্যাকচুয়ালি, দ্য টু পয়েন্টার মেথড। ওকে, সো নাও আই এম গোয়িং টু দ্য অ্যাকচুয়ালি ডি টাস্ক। ওকে, লেটস লুক এট টাস্ক ডি। ওকে, সো আপনারা একটু কোয়েশ্চেনটা পড়েন। এই কোয়েশ্চেনটা পড়ার পর আমি একটা জিনিস জিজ্ঞেস করবো। সো রিড দ্য কোয়েশ্চেন, আই উইল আস্ক সাম কোয়েশ্চেন অ্যাবাউট দিস। আচ্ছা, কেউ কি বলতে পারবেন এই টাস্কটা কি আপনারা আগে কোথাও করছেন বা পড়ছেন? Does anyone know, like, did you guys hear about this task anywhere else or read this task similar to this anywhere else, any other course?
Say 220.
Yes. So I took 220 lab for 1 year, I guess. So this same task is done in your 220 lab too.
Yes,
So
sir.
the solve you were taught in 220, because I also solved in 220 in a similar manner. So even in 220, you guys were actually using two pointer method, but you just didn't know the official term for it. Okay. So your 220 solve will also work for this one. Just you need to change the fast away part a bit. So let's look at the question a bit who do not remember. Alice and Bob are two friends. Alice has a list of length n in a non-decreasing order. So this is explicitly mentioned here. This wasn't mentioned in your 220 task. So even here, it is a non-decreasing array. And Bob has another array with length m and also non-decreasing order. Okay, now they want to combine the list. So we need to combine two lists into a single non-decreasing list. Length of n plus m, obviously, because we need to add up both the lists. However, they're not very good at algorithms like us. So they ask your help. Since you are a computer science student, you are tasked to write efficient. Okay. We need to basically merge the two given list, nothing else. But while merging, we need to maintain the non-decreasing feature actually. So the first line contains, let's look at the inputs. The first line contains the length of array, let's say 1, okay? This is array 1. And the third line contains the length of array 2, okay? Based on this, we are going to run loops and also combine our arrays. So this is just explained here. Even here, it is 10 to the power 6, 10 to the power 6, and our length is then 10 to the power 6 plus 10 to the power 6 max, okay? So it is also, let's say 10 to the power 6 into 2, right? So this is basically our max length. M space separate integers, okay. All the numbers given in the input file are within the 32-bit signed integer. So by signed integer, we mean also it can be minus values. Although the sample input doesn't contain minus values, but it can be possible, but it can stay, okay. So it is guaranteed that the given list will be non-decreasing order. So this is a guarantee. So let's actually join these tasks, okay. So how can we do it? Can anyone tell me? How can we join the two lists?
স্যার ব্রুট ফোর্সে তো স্যার কম্পেয়ার করে দুইটা লুপ চালিয়ে জয়েন করে দেওয়া যাবে।
Actually, that is the tasks we used in 220. That is not actually brute force. We also use two pointer. Let's see how actually. Like what you are saying is that we can combine two lists, then sort it, right? Are you talking about that one?
জি স্যার।
Okay, so we didn't do this in 220, I think. Like I didn't taught my students like that, but that is also a way, but that is obviously not efficient, because if we go for a brute force approach, obviously uh, time limit will be exceeded, right? Like here, it is 1 second. Again, since our length is high value, we cannot sort it and call it a day. And also we cannot use sort option here. Okay. So another thing, the inbuilt sort in both Python and Java, both are efficient. Okay. So we could have called and done the task, but it won't work actually. So we need to find a solve, which is two pointer solve here too. So let's simulate a bit, okay? So one, no, let's look at another scenario actually, not this one. Let's go with this one, okay? Because the lengths are different. I want to go with this one. So the first array, let's say array 1. This is 2, 10, 12, and array 2 is 3, 4, 6, 7, 8, 9. So we are going for a resulting array which will just combine these values, okay? So let's look at the solve actually. So first thing first, we need to compare which one is lesser than other value. Basically, among the two arrays, which index has the lower value? So let's say again, we have a left pointer and a right pointer, okay? So now, let's say I have array 1 in left pointer and array 2 in right pointer, okay? So the first value in left pointer is 2 and the first value in right pointer is 3, okay? So among this, which one is less? Obviously 2 is less. So I'm appending 2 here, the first element. So we need to compare now array values from both the arrays. So we are comparing left pointer with right pointer, but left pointer actually means array 2, array 1 left pointer, okay? And right pointer means I'm accessing array 2 right pointer. So for this task, just assume that left means array 1, right means array 2, okay? So even in this case, we are using 2 pointers, but it is not explicitly left or right. We are just using 2 pointers in 2 arrays. So still we can say this is a 2-pointer technique, okay? So we have appended 2. So now what will happen is that because we have appended 2, the left pointer, which was directing to 2, will now direct to actually the next value, which is 10, okay? 10. Now we have to compare 3 with 10, okay? But 10 is greater than 3, but we are going for a non-decreasing order, right? So in non-decreasing order, obviously the lower value gets priority. So we are now adding 3 from here. So after 2, we put on 3, okay? So the right pointer or array 2 value increases to this. Now 3 becomes 4 in the right pointer. Now tell me, do we switch the values or we still stay in array 2? We will still stay in array 2 because this is still the lower value. So again, we are appending 4 here and this becomes 6. So our array 2 or right pointer increases. Now again, we are comparing now 10 with 6, but obviously 6 is the lower value. Then 6, then this goes to 7, then still this is lower value. So 7 is appended. Then again, we go to 8. 8 is appended because 8 is lower value. Then also we're appending 9. Okay, 9 is lower value. Now the issue is, do we have any value to compare here? We do not, right? So if the left pointer or right pointer becomes empty or exceeds the number, sorry, it doesn't become empty actually. It becomes like this. Let's say our array length of 1 is actually n and array length of 2 is actually m. Okay. So the limit is less than n and here limit is less than m because our index is basically exclusive, right? We start from 0 to n minus 1. So in this one, our index actually exceeds. If we r plus plus, so this is 1, 0, 1, 2, 3, 4, 5. So after 5 index, it goes to 6, right? So 6, sorry, this is 5. This becomes 6. So our this basically exceeds our limit of maximum index value, right? So when this happens, what we do is we break the loop. We are using a loop here. Okay, let's say we are using a while loop. So we break the loop. But the issue is these two values are still remaining, right? 10, 12 values are not appended. So can anyone tell me what can we do so that these two values also can be appended?
স্যার একটা দুইটা while loop রাখবো, চেক করব যদি হচ্ছে লেফট পয়েন্টার ওর লেন্থের থেকে বেশি হয়ে যাচ্ছে কিনা। যদি না হয়ে যায় তাহলে ওই ভ্যালুগুলো অ্যাড করে দিব।
আচ্ছা, তো ঠিকই বলছেন যে আপনারা ইউজুয়াল যে লুপ, একটা লুপে আসলে এই টাস্কটা শেষ হবে না, ঠিক আছে? যদি কখনো এইভাবে if the lengths of the arrays are not equal, it cannot be done in one loop. So after finishing the main loop, we are using some precautionary loops actually. So let's directly look at the solve. It will be easier to understand actually. So let's look at a solve. Submission, beautiful sort. This one, let's try this one and this one. Okay. So let's look at the Python solve first. So the loop I talked about first, it is basically this one, okay? So this is like literally this loop I talked about where we need to compare the left pointer with the n, which is the array length 1, okay? Array length 1. And we need to compare r with m, which is array length 2, okay? Now the loop runs, but the issue is we couldn't append 10 and 12, right? So that is part of array 1 as far as I remember. Yes, array 1 had these two values. Now what will happen is that we still have the left pointer, right pointer values, right? So the left pointer, right pointer values, let's say our n is what, 3, sorry, n is 5 and our m is 3, okay? No, this is also 5. And let's say our left pointer is 3 and right pointer is 5, okay? So our L is less than n, right? Because this is the comparison. Since our left is less than n, we actually need to extend our array. Or we can say we have to append the answer array with the values of array 1, right? So the values which are left, we need to append those in the answer array. This can also happen in the opposite scenario where the array to length is actually less than, sorry, more than the array 1. So even in that scenario, we are comparing if the pointer value, the right pointer value is less than the length or not. If that is the case, then we are just appending the left out values at the last. So this will run, okay? Okay, another thing, what I have done here for Python people, star ends. So what does this star ends means? Okay, this means that if you have a list, okay, so in Python we don't have arrays, we have lists, right? If you have a list and you want to print it in a way which is 10, 12, 13, what you do is we use basically string concatenation, right? String concatenation, concat. But I have a few students actually DM'd me about this, that the Python string concatenation is very high in resources, okay, or high in time, very time consuming. So what would you do? You can use this approach because in most solves you are actually printing arrays, right? You're printing arrays as a string, just spaced. So if you just want a pre-built method which goes faster, you can use this format. So our answer is actually our main resulting list, but if we just add asterisk mark before it, it will show output in this format, and this is way faster than you using a loop to concatenate the values, okay? So you can go for this approach if you are using Python, okay? So let's look at the Java solve. This is the Java solve. It is basically the same, but in Java, these tasks are not time consuming, okay? So we are just adding up the values and also at the same time printing it, okay? But because of the printing resource issue, we are using what print writer. Print writer, I'm just assigning to a variable value, then printing it out through it and not using scanner actually, right? I hope you guys know that, and also buffer reader to read the values. So in this solve also, let's look at this. The extra while loops are because of the extra values which still remain in one of the arrays. So we are just at the last appending it in our main array. So I'm kind of sure that your lab faculty in 220 also taught you this solve in the same way. So if you even revision the 220 code, you would find a similar solve, just not the efficient one in a sense. So does anyone have a question about this task or solve actually? কারো কোনো কোয়েশ্চেন আছে এই সলভ নিয়ে? বুঝছি, রাইট? মানে প্রথমে যেটা করবেন, দুইটা অ্যারের মধ্যে কম্পেয়ার করবেন, কোনটার ভ্যালু লোয়ার ওইটা আপনি আগে অ্যাপেন্ড করবেন, আর ওইটা অ্যাপেন্ড করার মানে হলো ওই অ্যারের যে ইন্ডেক্স আছে ওইটাকে আপনি ইনক্রিজ করবেন। সো এটাকে আমরা ধরতেছি লেফট পয়েন্টার হলো অ্যারে 1, রাইট পয়েন্টার অ্যারে 2, এভাবে ইনক্রিজ করে করে ইন আইডিয়াল সিনারিও আপনার এই লুপের মধ্যে, ইন আইডিয়াল সিনারিও ইন ওয়ান লুপ দিস উইল ওয়ার্ক, বাট ফর সিনারিওস ওয়্যার n and m do not match, so the array length do not match, there we need to go for this approach too. So we need to run two separate loops which could append in any scenario. So it could the scenario could be this or this, but not both at the same time, right? So this is how we can actually solve this. So for Java people, remember to out.flash, because without this, sometimes you could get a memory exceeding issue, but in most cases you won't actually, because the problems have a high amount of actually output, like 256 MBs. Usually it is in KBs, our usual solves. Okay, so but it's still a good practice to do efficiently, right? So does anyone have any question with a beautiful sorted list question? This one?
Yes, sir, I have questions.
Okay.
Sir, second linked list, if it is not, sorted. So we got the 10 in first linked list. We are comparing with those number, those are, sorted.
Yes.
If they are not sorted, we got like 8. Then after that, we have 5. How you say compared to this?
Actually, in this task, it is explicitly mentioned that it will be non-decreasing. Okay, so in no scenario you will get that anomaly that array is not sorted. Okay,
Yes, sir.
so for this solve, it needs to be sorted. So without the sorting, you can say it won't work actually. Our usual solve or this solve. So if you want to do this process in a let's say unsorted array, you can first sort the arrays, then go for this approach. Okay.
Okay, sir, I got it.
Okay. So আর কারো কোনো কোশ্চেন আছে? আচ্ছা, হোপফুলি নাই। সো এইটাতে অ্যাকচুয়ালি আমরা আর বাইনারি সার্চে যাচ্ছি না, এটাতে এই 2 পয়েন্টার দিয়েই একটা ভালো এফিশিয়েন্ট কোড হইতেছে। বাইনারি সার্চ অ্যাকচুয়ালি এখানে মেক সেন্সও করে না, কারণ উই আর লুকিং ফর indexes in both arrays. So binary search actually won't work because binary search doesn't work on two arrays, right? And we are comparing two arrays, and the values are mainly we are looking for a non-decreasing order, so nothing much. So I think two-pointer method is more efficient in this scenario too. Okay. Okay, so let's go for the last question of today. The longest sub-array sum actually. I think even this solve is similar to a task to 220 actually. So you guys kind of read it and let me know if you guys find it similar. আচ্ছা, ওই hopefully পড়ছেন অনেকে. So is this task also similar to you guys? Have you guys done this task anywhere else, like 220 or 111 somewhere else? No? I think a similar task was there in 220. Yasin, do you want to say something?
Sir, I'm not sure, but it seems easy.
Yeah, it seems easy, and a similar task was actually also done, I think. I'm not sure completely, but let's see the task. It's
Yes, sir.
longest sub-array sum. I think the timing was a bit different then. You are given an array, n integers, and an integer k. Okay, so n integers. So basically, the first input is again length of array. So length of array. And The second value is basically just an integer k. We are going to k, like what is this k? Your task is to find the length of the longest contiguous subarray. So this term may be a bit unknown to you guys. I think the term was a bit different. So contiguous subarray, it means that the longest adjacent subarray. So by that, what we mean is that basically বাংলাতে যদি বলি আমরা পাশাপাশি কত বড় সাব-অ্যারে বানাইতে পারি যেটা সাম হবে আমার টার্গেট ভ্যালু। ওকে, সো we are looking for a sub-array. Basically, what is a sub-array? Sub-array, let's say 1, 2, 3, 4, 5. So here, this is a whole array, right? This is a whole array. 1, 2, 3, 4, 5. Now let's say I'm taking 4 and 5. So what is this? This is basically the sub-array of 1, 2, 3, 4, 5 if we just take these two elements. But we cannot take it like this. Like I cannot take 1 and 3 and call it a sub-array because that is not continuous or adjacent. So if we compare where there is left and right adjacent values, we can call it a sub-array. We can call also this a sub-array because these values are adjacent to each other. So by this, it is meant that contiguous subarray. So we are looking for sum which is less than or equal to k, and it is from the longest contiguous subarray. Okay. So now we're looking for a target value k. Even this time we are looking for sum like task 1. But in task 1, we looked for AI and AJ, which is just two elements. But in this case, it can be more than two elements, and the sum has to be the target again. Okay, so this is somewhat similar to the you can say which one, task 1 actually. But in this case, you do not need to print the index number or the sum. You need to print a single integer, the length of the longest contiguous subarray whose sum is less than or equal to k. Okay, so you need to run the loop and you need to print which is the length of the contiguous subarray for a closer value to k. Okay, so let's look at a simulation of this. এমনি কোয়েশ্চেনটা কি বুঝছি সবাই, যে আমরা একটা সামের দিকে যাইতেছি যেখানে আমরা পাশাপাশি অ্যাডজাসেন্ট যেই এলিমেন্ট গুলো আছে ওটা কতগুলা পর্যন্ত নিতে পারি, জাস্ট লেংথ। আসলে এই একটা সলভ দেখলে বুঝবে না। আই হোপ ইউ উইল আন্ডারস্ট্যান্ড আফটার আ সিমুলেশন উইচ ইজ 5 is our n. Okay, n is 5 and our target value k is 4. So we are going for 4. Somehow by summing we are reaching to 4, but the sum has to be less than basically কি বলে less than the target. Okay, so this solve I won't show you the code, I'm just going to give you some hint. So how can you approach this problem? So in for this problem, obviously you go for the 2-pointer, but this is specifically called sliding window task. Okay, the term is sliding window. So in these kinds of solves, what happens is that for the 2-point, what is the difference between 2-pointer and sliding window? I'll give it in short. You can also search about this a bit. So in 2-pointer, what we said is that the left pointer needs to be less than the right pointer. But in the sliding window problem, this doesn't need to be true. Okay, so we can change the array ordering or the pointer ordering as our wish or as our need basically. So let's start from 0 index. Okay, so in this case, we start from the 0 index. Okay, so our left pointer and right pointer, let's say left pointer is 4, and right pointer is also pointing to 4. So no, sorry, 18. This pointer is also pointing to 4. So we have already reached our target value in the first case, right? But we want to find the longest subarray. Okay, longest subarray. So we can say our output is 1 now. This is a 1 solve, but now let's increase the right array. So the right pointer. So 4 plus 1. So is that equal to our target 4? No, actually, right? Our target is 4, but this is 5. Now a simple comparison is needed actually. Back. The sum is 5 and our target is 4. So Do we need to increase the sum or do we need to decrease the sum? This is our sum. This is our target. Do we need to increase it or decrease it? Someone tell me.
Decrease, sir.
Decrease, right? And even in this case, it is a non-decreasing or sorted array, okay? Oh, no, sorry. In this case, it is not. It is not a non-decreasing array. Okay, but for the sliding window method, what we do is that we usually go for the left pointer, not the right. We move the right pointer, okay. But if we see that our what we can say is that this or our let's say sum, if the sum is more than our target, if this is yes, we don't move the right, rather move the left and minus the sum from the answer, okay. So we are seeing that because of the left pointer, it might be an issue, or our target value is less. So in that case, let's change up the left pointer, okay. So the left pointer now goes to 1 and our right pointer will go to 2, okay. And what we can do, we do not need to sum again. What we can do is that we can just remove 5 minus 4, okay. 5 minus 4, which is 1, and sum up this, so plus 2. So this is 3. So what is different here is that we need to keep the sum in a variable, and whenever needed, we need to minus basically sum minus array of L, okay. So if we are increasing the left pointer, we need to decrease that amount from the sum value. Then we are adding up the right value, okay. So array of right will be added here. বুঝছি এই জিনিসটা? এটা করলে আস্তে আস্তে আমরা সলভের দিকে আগাবো আর কি। So in this case, left pointer, right pointer anyway can be shifted. So let's increase this. So what we need is, because 3 is still not our actual value, and it is less than our target value. Okay, it is less than our target value. So we can go 1, then this can go up to this one, right pointer. So this is now 1. Then our sum is basically 1 plus 2 plus 1. So this was already done, right? 3, this part. Now let's increase the right value again. So 1 plus 2 plus 5. Okay. But in this case, the target, oh, sorry, we have reached the target already. Sorry. So this is 4. So we have reached our target actually. So from this, we can say the length of the subarray is 3, and that is our output. Okay. So this is a kind of different approach, not your usual 2-pointer approach. This is called sliding window approach. Again, I'm saying that we need to start from the same position, left and right, from the 0 position. Then we check if the sum is more. If the sum is more than our target, then we change the position of the left pointer and also decrease it from the sum value. Okay. And we can also keep another counter value, okay, counter value, so that we know the length. What is the length now? So that needs to be changed sequentially too, okay. So I'm not going to the code of this, I'm just showing you another example. Like here, our array length is 5 and our target is s, okay, which is 5. So is it possible to make 5 from here? It is possible to make 5 from here. So 5 of the elements are just going to be summed, okay. Then that is our output also, because the length is also 5. So let's say this doesn't work actually, like this one. Here the target is 1, but there is no single element where it is 1 or less, right? So our solve is actually not in this array. If that happens, we can just run output 0. And the last one, it is 12. 12 can be made in a few options here, but to find out the max one, we are going to sum 4, 5, 6, 7, 8, 9, 10, 11, 12. So the subarray length is 1, 2, 3, 4, 5. Okay. So through the sliding window method, we can go to this solve 2. So here is also the explanation of the things here. Among them, which is the longest? The longest is 1 to 1. That is why we have printed this. So কারো কি কোনো কোয়েশ্চেন আছে এটা নিয়ে? কেমনে? এটার হলো কোডটা আমি দেখাবো না, আপনাদের নিজের একটু ট্রাই করতে হবে এটা।
স্যার, কাউন্টিং যে ভ্যারিয়েবলটার কথা বলছেন ওইটা কি এট দ্য এন্ড অফ দ্য মানে সিকোয়েন্সের পরে যে ওই সাব এর লেন্থ বের করার জন্য?
হ্যাঁ, সাবেরের লেংথ। মানে আপনারা সবসময় আগাবেন পিছাবেন, বাট একটা হলো কনস্ট্যান্ট রাখবেন যে এটাই হলো আমার ম্যাক্স কাউন্ট। ঠিক আছে, লেংথের ম্যাক্স কাউন্ট। ওইটার চেয়ে বেশি যদি আমি না পাই তাহলে আমি ওইটা প্রিন্ট করব না।
ও
বুঝছেন?
আচ্ছা, জি স্যার। আর স্যার, এই কাউন্টটা কি আমরা লেফট আর রাইট ইনক্রিজ করার সাথে সাথে ইনক্রিজ করব, নাকি একদম শেষে যে লেফট মাইনাস রাইট করব?
আচ্ছা, এটার কাহিনী হইলো প্রতি আফটার এভরি ইটারেশন, ইফ ইউ ইনক্রিজ দ্য লেফট পয়েন্টার, ইউ হ্যাভ টু ডিক্রিজ দ্য লেংথ, অ্যান্ড ইফ ইউ ইনক্রিজ দ্য রাইট পয়েন্টার, ইউ নিড টু ইনক্রিজ দ্য লেংথ। ঠিক আছে, মানে হলো আপনার লেফট পয়েন্টার যদি আগান তার মানে কিন্তু আপনি কমে আসতেছেন। ঠিক
জি
আছে,
স্যার।
লেংথ কমতেছে। আর আপনি যদি রাইট পয়েন্টার বাড়ান, রাইট পয়েন্টার কিন্তু রাইটে যাবে, তার মানে হলো আপনার বাড়তেছে লেংথ। এইটা মাথায় রাখতে হবে।
ওকে স্যার, থ্যাংক ইউ।
আচ্ছা, আর কারো কোনো কোয়েশ্চেন? আচ্ছা, হোপফুলি নাই। সো আপনাদের এই ল্যাবটায় মোট টাস্ক হইলো, হয়ে গেল। So there are A to H tasks. So using this two sum problem, I think you can do the B and C part. D and C has been showed to you